Okay, so in this video clip, I'm going to take a look at a paper, an SSRN paper. I think it may also have went into a Journal of Finance Education as well. If I'm correct, I mightn't be correct on that. It's a very popular paper, so heavy usage. And when you read through, you can kind of see why. So first of all, it's a calculating the VIX index in Excel. There's no VBA whatsoever. There's a little bit of reference here in terms of what's going on. It's to calculate the volatility index, S&P 500. This manner of the VIX emerged in September 2003. It's documented by an example, with an example by the CBOE. So I've already downloaded this paper, and if we go in, we see that there is an actual sample provided by the CBOE back in 2003, explaining how, if you had this basic raw data of option chain numbers in terms of calls and puts, for each of the respective prices, we have a mid-price call between the bid and the ask, a mid-price put between the bid and the ask, and we have the same also for a 44-day maturity set of options. So basically, we've a near-term options, we have the next term options, which are 44 days, 16 days. And so if you like, ultimately we're going to try and interpolate to a 30-day window, okay, because that's what the VIX represents. The VIX is intended to provide an implied volatility estimate for a 30-day window, although annualized, okay. Now, the interest rate here is given to be 1.1625. Okay, so this paper was in 2007, but the example is 2003. And then Arnold sets out a spreadsheet, and we can see the cell referencing. Okay, so the cell referencing A, B, C, and then each of the respective numbers. So each number here, each bit of data that's presented, we can identify that by the cell reference, which is useful then in terms of implementation. Now, what I tried to do, right, was to replicate Arnold's spreadsheet and follow as closely as possible the cell functions. Okay, so each cell, when estimated, Arnold and Earl reveal how to make the estimation, right? And I go along with that as much as possible. One or two small bits of information, parts of the estimation I do ultimately change. Okay, so let's open up the spreadsheet then where I made this estimation, and I have a few things here. There is I took the original numbers as presented with Arnold, okay, as set out, and a few minor changes were introduced as the estimation was being done, and the one where that change was made, I'll highlight that in a moment. Okay, so let's just run through here again the VIX in the example given by Arnold. Let's open it up in PDF. Okay, we have our raw data, and then we want to estimate the VIX. And I've already a video clip why the VIX index is relevant, and why it's constituted as a fear gauge, why it's commented on in the media frequently, and its significance. Okay, and I'll put a link to that video below. So basically, in estimating the VIX, we're trying to estimate an implied volatility measure. We're not using Black-Scholes here. It's not the whole raison d'etre of the VIX index is that it's not dependent on any particular model. It's model free. The data, the information that we have here is from the 2003 example. In other examples I've put up on YouTube, there was much more involved set of figures. Okay, so this has the attraction of being relatively simple in terms of scale, and may be useful then as a kind of a tool. So let's go in and take a look at the information presented in Arnold. So the starting information is that we have, it's currently 8:30. There's 16 days to the first contract. Normally in this VIX estimation we have option chain data for 2 dates revolving around a 30-day window. The first is a 16-day contract, so 16 days between now and when the contract expires, and the second contract, the further contract, is 44 days in all, and we have to convert these days with the time into ultimately, I suppose, minutes, and then into years. Okay, but our raw data, if you like, is basically we have strike data, we have the mid prices for a call, mid prices for the put. Mid price would be the average between the bid and the ask on the call, and the put price here for the shorter term, the near term contracts is the average of the bid and the ask on the puts. Okay, so every market has a bid and the ask. Okay, so this is raw data. In the box here we have raw data, and again if we come down we have raw data again for the 44-day contract, with again a smaller number with it. We have 10 or so strikes, and then mid price for calls, mid price for puts. Okay, so that's our raw data essentially. Okay, our raw data is the maturity of the contracts, the interest rate, the annual interest rate, APR, relevant for 30-day window. And if we look at that, it's actually 1.1625. And then we have to implement a formula, a model-free formula, to estimate the VIX estimation. Now, as part of that VIX estimation, we have to calculate the variance on each of the time periods. Okay, so we have to implement this formula here, and there's a few components here that are relevant. And a nice thing about the way Arnold presents the information, the example given by CBOE, is that everything is coded up purely in terms of cell referencing in Excel, without any reference to VBA or more complex type implementations, and that's somewhat desirable, in particular when we're setting out to try and gain some kind of insight in terms of working through the estimations. Okay, so everything here in terms of our estimation is cell referenced, and we can track it in a reasonably straightforward fashion. Okay, so we have the near-term contract, 16 days. The further term, the next contract on beyond the 30-day window, 44 days. We've got to convert the expiration, if you like, into maturities. And we have to do it in a way that's actually fairly exact, because given the that we're down to days, we typically will convert the maturity in terms of minutes, and that's just to add an extra amount of precision that not normally is observed when we're valuing options or addressing options. Okay, so again, I follow pretty much in line with what's outlined by Arnold and Earl in their paper. If we look at the cell referencing I have here, I follow pretty much along the same. In fact, it's exactly the same, and I try to preserve the same cell referencing as Arnold. Okay, so let's take a look then in terms of processing the maturity. Now cell D5 is equal to this. Okay, so that's the explanation that's given. I follow in line with that exactly, and no difference, right? Maybe we could have hit F4 here just to follow the sequence the same as Arnold and Earl. Okay, so what's going on here? Well, a couple of things. We want to estimate the maturity and convert to minutes. And in the approach adopted here by Arnold and Earl, basically we take this B3 is the 16 days, and we say, okay, look, it's currently 8:30 in the morning of at the current time period. There are 16 days over which this contract spans. Okay, an important consideration here for this 2003 example, we only consider, importantly, settlement, if you like, at 8:30 in the morning. And why that's important is that helps us to explain why 510 is added in here. So if I follow the code set out by Arnold and Earl, we have this 1440. It represents what? Well, the 1440 might be understood to mean the number of minutes in the day. So if there's 60 minutes in an hour and 24 hours in a day, then the number of minutes in one day is 1440. Okay, so coming back here, this 1440 is the number of minutes in a day. We want to take the next section then in terms of the formula set out here is we want to convert the time period here, 8:30 in the morning with 0 seconds, into units for hours, minutes, and seconds. Okay, and if you like, we then divide this. When we could isolate this and just see what each of these, when we take them together, right, what they represent. So let's just copy that for a moment. Copy and just escape, paste. Okay, right click and paste. And we'll put equals again, should have equals. And we get 12. Now just disregard that for a moment because we need to convert into, we should customize that to be general. Okay, and we get this 510. In other words, if we convert 8:30 in the morning, 8 hours and 30 minutes in the morning, into minutes, it's 510 minutes. Okay, so this hour, B3 minutes, B3 seconds, B3 is converting each of these into, we're saying we have an hour of 8 hours multiplied by 60, and we have minutes which would be 30, so we can break them into minutes. Okay, so 510 minutes have already passed since the beginning of this day. How many minutes are left in the day? Total number of minutes in a day would be equal to 1440. If we subtract 510 from 1440, that's the number of minutes remaining in the day. So equal to 1440 minus 810, we get 930 minutes. So 930 minutes remain from 8:30 until the rest of the day. Okay, so I'll continue the rest in video 2.